Alright, so today's lesson is 4-4, scientific notation. And look, we're back. Miss Golden's wearing the same clothes in yet another video. I know, it's the same day for me anyways. Okay, so the first thing we're going to do today is in our composition books, we're going to turn back to that foldable we glued in several lessons ago. And we're finally going to finish filling in the last part of this one. Okay, because all of this is from chapter 4. We had 4-1, 4-3, and now 4-4. So on that bottom section, we're going to write scientific notation. So scientific is SCIENTIFIC. Notation is NOTATION. Scientific notation. Okay, then once you get that written down, you're going to open it up. And in that bottom section, we're going to write a definition and an example, okay? So over here on the board, your definition says scientific notation is a number expressed as a product of a factor and a power of 10. Okay, so then we have a times 10 to the nth power. So a and n just mean for any number and an exponent, where a 1 is less than or equal to a is less than 10 is what that says. But that just means your a, that number out front, has to be a single digit number, less than 10, and it has to be positive, so 1 or bigger. Then it also says and n is an integer. That means your exponent over here, n, can be a positive or a negative number. That's all that means. So then we have two examples. We have 3,500,000 equals, well, in scientific notation, that's 3.5 times 10 to the 6th power. Then we have a decimal, 0.00004. That would be 4 times 10 to the negative 5th power. So I'll try my best to get this over here where you can get all of it without me in it. So you can pause the video there and write all of that down, and then we'll start looking at some examples. So looking at scientific notation, we're going to start out by seeing problems in scientific notation and writing them in standard form. Standard form just means the original number. So whenever you have, let me start out by saying scientific notation is always times 10 to some exponent. Okay, so looking at your exponent, it tells you a lot. If it's a positive exponent, it means it's a whole number or a number bigger than 1. So you'll hear me say it's a big number. That just means bigger than 1. If it's a negative exponent, it means it's a number less than 1, most of the time a decimal. Okay, so looking at A, we have 2 times 10 to the 3rd power. So your exponent tells you how many times to move your decimal. Well, we have a whole number 2 out front. So that means if there were a decimal on it, it would be behind the 2. We would take that and move it 3 times. Since we have empty place values, you would put zeros. So we have the number 2,000. On B, we have 6.8 times 10 to the 5th power. So that tells me it's a big number because it's positive, and it's 6.8, so we take that decimal that's between them, and we move it 5 times. It doesn't always mean that that's how many zeros you add, because on this one, if we move it 5 times, 1, 2, 3, 4, 5. We're going to have to go back and just add 4 zeros because it had to move behind the 8. So this number, if you put commas, would be 680,000. On C, we have 3.25 times 10 to the negative 4th power. Since it's a negative, it also means you go to the left. Up here on both of these, we moved to the right because on a number line, your numbers are getting bigger going to the right. Going left, they're getting smaller. Negative exponent tells me it's getting smaller. So I start with my decimal, which is behind the 3. Sorry about that bell. Again, that was in the video, not in class. So I take this decimal and I move it 4 times to the left. So I'm going to have to add some zeros. Now, my decimal is now out front. So it is 0.000325. So you're going to try A, B, and C, 1A, 1B, and 1C, writing them in standard form. So pause the video, do that, and press play to check your work. All right, on these problems, we were writing them in standard form, which means we're kind of undoing the scientific notation. So anytime you have a positive exponent again, that means it's a big number, okay? Positive is a big number. So we would take this 4, the decimal would be behind it. Since it's a big number, we would move that 2 times to the right. Remember, just like on a number line, everything gets bigger to the right. So then you would add in zeros in those spaces. So 4 times 10 to the second power is 400. Okay, on 1b. Again, it's a positive exponent, which tells me it's a big number, so we're going to move our decimal to the right 7 times. So right now the decimal is behind the 5, so if I move it 7 times, 1, 2, 3, 4, 5, 6, 7, I'm going to have to add 5 zeros in there. So my number is 59,400,000. Okay, then on 1c, it's a negative exponent, which tells me it's small, which means we're going to move the decimal to the left. So 1.3, I have to move it 3 times to the left. 1, 2, 3. I add in 2 zeros. So my decimal is still out front, so 0.0013. If you put a 0 out front, that's fine. You don't have to, but it's 0.0013. So example 2, now it says express each number in scientific notation. So they give us the original number and we're going to write it using scientific notation. So on this first one, we have the number 4 million. So that's a whole number, so our decimal would start out at the very end. Okay, so when we're writing scientific notation, if you notice that I like this little sticky note over here, that's supposed to be a star, whatever. It says when numbers are expressed in scientific notation, no more than 1 digit is to the left of the decimal point. So that means my final answer will only ever have one number out front of the decimal anyways, to the left, when it's in scientific notation. So since these are all zeros, we only care, well, we care about the zeros, but we only mainly are worried about the numbers that are not 0. So when I'm writing this in scientific notation, I want this decimal to end up right behind that 4. So we have to move it 1, 2, 3, 4, 5, 6 times to make that happen. Since this is a number bigger than 0, we know, or bigger than 1, we know our exponent is positive. So we're going to have 4 times 10, and we moved that decimal 6 times to get it there. So it is 4 times 10 to the 6th power. Okay, so now B, we have 0.072. Since this is less than the number 1, we know our exponent will be negative. Okay, so now we've got to move that decimal. We write, let me say that again. When we're writing it in scientific notation, we're going to write every number that's not 0. If there's a 0 between them, we write it, but all the ones out front and all the ones at the back, we don't write. That's the whole point of scientific notation. So we want this decimal to be behind the first non-zero number. So we want the decimal between the 7 and the 2. So we move it 2 times to get it there. So it's going to be 7.2 times 10. We moved it 2 times, and we already said since this number is less than 1, it is negative 2. Okay, real quick side note. So many people keep asking me why we need scientific notation. These numbers, when you get huge decimals, okay, decimals, all of these decimals are less than the number 1. So when we get it where it's going way out with tons of zeros, it gets very confusing. Well, in science, that's why it's called scientific notation, it was made for science because when they're measuring things like on a microscope or weighing things that are so tiny that you can't even hardly see them, we have these super, super small numbers with all these zeros. Well, to make it accurate and not get confused on how many zeros you see, we can write it in scientific notation so we can clearly see exactly how many spaces there are in that decimal. That's kind of the whole idea of why we have scientific notation. Okay, so now from that, you're going to do 2B and 2C only. I'm not going to make you do 2A. Okay, so 2B and 2C, you can pause the video and try those. I'm going to go ahead and move on to example 3 before I work those out. I'll work those 2 out after I do example 3. So you can pause the video now. All right, so now looking at example 3. It says the population in Kansas, or of Kansas, is 2,853,118 people. Write an estimation in scientific notation for the population. That kind of sounded like it rhymed. But anyway, okay. So we are estimating. So that means we're going to go ahead and take this really big number and round it. So you look out front, we have a 2. Looking directly behind it is an 8. We're not worried about all these digits. 8 rounds up, so that 2 becomes a 3, and then we just put zeros for all the other numbers. So all we did was we said 2,853,118 is approximately 3 million. Then we write it in scientific notation because it's much easier to do from this number. So it's a big number, so it's going to be a positive exponent. My decimal starts at the very end, and we're going to move it 1, 2, 3, 4, 5, 6 times to get it behind that 3. So it will be 3 times 10 to the positive 6th power. That means the population of Kansas is about 3 times 10 to the 6th people. So you are going to estimate. I'm only going to make you do 3A. Okay, so you're only having to estimate on one of these. So round it first, then write it in scientific notation. Okay, so you can pause the video and try that. Then I'm going to go over 2B, 2C, and 3A for you. All right, on 2B and 2C, we were writing them in scientific notation. So on 2B, it's a large number, meaning it's bigger than 1, okay? That's what I mean when I say large number with scientific notation. So we know our exponent will be positive. So right now, our decimal, since it's a whole number, would be at the very back. Okay, well, we want the decimal to end up behind that first number that's not 0. So 1, 2, 3, 4 times to get it there. You write down everything that's not 0 times 10, and we moved it 4 times. So 1.89 times 10 to the 4th power. On 2C, this is a very small number. It's less than 1. So my exponent is going to be negative. So first, let's see where we want our decimal to be. We want it to be behind the first non-zero number. 1, 2, 3, 4, 5. We had to move it 5 times to get it there. We write everything that's not 0. Times 10, we said 5, but since it was a small number, it is negative 5. Now, on 3A, we are estimating. So, first, look at your front number. We have 3. Look immediately behind it. It's a 6. We're going to round this number. 6 rounds up. So, all of this would be 4, and then put zeros everywhere else. Because we are estimating. So, we're getting about how many or how much. So, now writing this in scientific notation, my decimal's way back here. It's a very big number, so I'm going to have a positive exponent. I would move it 1, 2, 3, 4, 5, 6 times to get behind that number. So 4 times 10 to the 6th power. Now your decimal is here, but since there's nothing else, you don't have to put it. We know it's behind the 4. So 4 times 10 to the 6th power centimeters is about how much that is.